Today we will discuss about theory of equations. So it is the fourth chapter in mathematics 2A. So in intermediate the weightage of this chapter is 7 plus 2 is equal to 9 marks. One 7 marks problem and one 2 marks problem. So we will see what are the topics we have in this chapter. So first of all we should know about polynomial. So what is polynomial? So P of x is equal to a0 plus a1x plus a2x square plus up to so on plus an x power n. So this is a polynomial with degree n. So highest power of the polynomial is degree. So what is the degree of this polynomial? N. So degree means highest power. For example, P of x is equal to 3x square plus 5x plus 6. So the what is the highest power of this? 2. So degree is 2. So this is polynomial. So in this chapter we have polynomial equations. So what are polynomial equation means? P of x is equal to 0. So for example ax square plus bx plus c is equal to 0. So if any value, so satisfying this equation, so P of alpha is equal to 0 means alpha satisfies this equation, then alpha is the root of this equation. So alpha is the root of this equation. Alpha is the root. So polynomial equation, if any value satisfying this equation means in place of x if you substitute alpha then you will get 0. Then we will say alpha is the root. So this is about polynomials. Next we have remainder theorem. Remainder theorem. So what is remainder theorem? So let f of x is equal to f of x be a polynomial with degree n greater than 0 and a belongs to C. A belongs to C. Then there exist q of x such that f of x is equal to x minus a into q of x plus f of a. F of x is equal to x minus a into q of x plus f of a. So here q of x is the quotient and f of a is the remainder. So for example, if x is equal to a, then it will become f of a is equal to, so this will become 0. So 0 plus f of a. F of a we will take as c here. C. F of a is equal to c. So means f of a is equal to c. Means remainder theorem means for any polynomial with degree n greater than 0 there exists a value and q of x be the coefficient such that f of x is equal to x minus a into q of x plus f of a. If you substitute x is equal to a, then f of a is equal to c. So this is the remainder theorem. So this is the concept of remainder theorem. Here x minus a is the factor of f of x. X minus a is the factor of f of x. So this is about remainder theorem we have. Next, now we will see the relation between coefficients and roots of a polynomial equation. So relation between coefficients and roots. Coefficient and roots. For example, you have quadratic equation ax square plus bx plus c is equal to 0. So then alpha comma beta are the roots. Alpha comma beta are the roots. Now, first condition we have sum of the roots. Sum of the roots. Sum of the roots. So, S1 is equal to alpha plus beta. So, S1 is equal to formula minus B by A. So, S1 is equal to sum of the roots alpha plus beta. So, S1 is equal to minus B by A. Next we have product of the roots. Product of the roots. So, S2 is equal to alpha beta. So, S2 is equal to C by A. So, S2 is equal to C by A. So, this is product of the roots. Means when we have quadratic equation, means degree 2, then we have 2 roots. Then we have 2 conditions. Means based on the degree we have number of roots and number of conditions. So, when degree is 2, 2 roots, 2 conditions. So, sum of the roots is minus B by A. So, here we have to take the minus x coefficient by x square coefficient. Next, C by A, constant by x square coefficient, like that we have to take. So, this is the relation between coefficient and the roots when we have quadratic equation. So, similarly when we have cubic equation, ax cube plus bx square plus cx plus d is equal to 0. Then what is the relation between the coefficients and roots? So, we will see. So, alpha comma beta comma gamma are the roots. 3 roots we will get because degree is 3 means 3 roots. So, alpha beta gamma are the roots. So, first sum of the roots S1 is equal to alpha plus beta plus gamma. So, S1 is equal to minus B by A. Next, S2 is equal to alpha beta plus beta gamma plus gamma alpha. S2 is equal to alpha beta plus beta gamma plus gamma alpha. S2 is equal to C by A. Next, here 3 roots, 3 conditions we will get. Last one is product of the roots. S3 is equal to alpha beta gamma. So, S3 is equal to minus D by A. Minus D by A. See, always first condition is sum of the roots, last condition is product of the roots. So, here how to take the conditions are, first condition S1 minus x square coefficient by x cube coefficient minus B by A. Alternate plus minus. So, after minus you will get plus. S2 is equal to next x coefficient by x cube coefficient C by A. Next S3 after plus minus plus next again you will get minus constant by